Hi, section 2.5. Section 2.5, there are two terms that we are going to use here. And these two terms, one is and the other one is or. And where do we use this in algebra? Let's assume that you have two sets. There is a set of A that has these numbers in it. 1, 2, 3, 4, 5. So let's assume there is a basket that there are 5 numbers in it, like 5 balls, and we label those 1, 2, 3, 4, 5. And there is another basket, we call it basket B, and there are only 2 balls into this one, 2 and like 4. Okay? So we have 2 different baskets. One has 5 balls or marbles, and we label those 1, 2, 3, 4, 5. And again, the second one is 2 and 4. Now, what is A and B? Or they call it, what is intersections of A and B? Intersection of A and B is when you overlap these two. What do they have in common? They both have 2 and 4 in common. So 2 and 4 both are in common here, right? So intersections of A and B, say A, and we use this symbol too, A and B is 2 and 4. So when you overlap these two, they both have these two numbers in common. And what is, and we say A and B, or we just show these symbols. The other one is OR. Let's say I want to have one basket and threw all these numbers into this basket. So what I have is all numbers. So when I put all the numbers into this basket, I don't want to repeat a number more than once. So when I take all these 5 and put it here, then I don't need the other one because this one already has 2 and 4. That's the union. So A union B is all these numbers. Okay, that's what union means. You have all the numbers inclusive. Let's look at another examples. So here you have again 1, 2, like 3, 7. The other basket you have 1, 4, 7, 10, 12. Okay. What is intersection of A and B? What is A and B means? What number do they both have in common or share? They both have 1 and they both have 7. So when you overlap these two, they both have these two numbers. So this is A and B, means intersection, or when you overlap two sets, they both share these numbers. Now, what is A union B, or A or B? You need to have all the numbers with no repetition of a number. So this one has 1, 2, 3, and you have 4 here, 7, 10, 12. See, you have all the numbers with no repetition of numbers. Like you see, I have here 1 and 1. I'll just put one of them here. 7 and 7, I'll just put. So that's what the union means. So we are using this idea of and or for inequalities. All right. Let's look at these examples. Solve the compound inequality. Compound inequality means when you have more than one. One is x less than 4, and the other one is x greater than -4. All right. So let's graph this one first. So x less than 4 is this one. Okay. And the second one is x greater than -4. So if this is -4, x greater than -4. So it goes all the way from -4 to positive infinity. The first one goes from 4 to -infinity. Now, when you overlap these two, they both share this part. See? They both have these two sections when you overlap. So and is -4 and 4. That's how you find intersections. So they both have this part in common when you overlap. Another example is you want to solve the compound inequality which has x less than -4 and x less than 4. X less than -4 again, since there is no equality sign, then you use the parentheses. The other one is x less than 4. Okay, that is so. And again means you overlap these two to see what part do they have in common. They both have this section in common from here to here. They both have this section in common, right? So one end is -4, and what's the other end? -infinity. That's how you put the answers. So the answer is -infinity and -4. So that's your solution set. They both have this section in common. Solve compound inequality. All right. So now this time I have these two. So the first one is x greater than or equal to 4. Second one is x greater than or equal to 1. Okay, so x greater than equal to 4. We put a bracket because there is an equality sign. Okay, otherwise it was parentheses. The other one is x greater than 1. See, that's the next one. So when you overlap these two, they both have this piece in common. See that? They would have this piece in common. So one end I should put the 1 here, I'm sorry. Because 1 is small, right? So the common would be here. Sorry about that. So they both have, one end is 4, the other one is negative, positive infinity. Okay? Because 1 is smaller than 4, right? So it's like that. Solve compound inequality. 5x plus 1 less than minus 14 and 4x is less than equal to 0. We divide both sides by 4. 0 divided by 4. What is 0 divided by 4? Use your calculator. It's 0. Anytime you have a fraction, the numerator is 0, the outcome is always 0. And as I said, you could verify that by using your calculator. So this is what I have right now. X less than equal to negative 3. The other one is x is less than equal to 0. And they both have and, means intersections. So what is the intersection of these two? They both have this part in common. See that? So it would be minus 3 bracket minus infinity. Infinity always take a parenthesis, never take a bracket. So that's how you write answers. Minus infinity, comma, minus 3. Solve the compound inequality. So the first one is negative 2x is less than minus 8. We divide both sides by negative 2. And remember, when you divide by negative, you must switch inequality sign. Don't forget that here. Okay. The sign would switch because we are dividing by negative. It's greater than 4. And less than 9. The word is and, means you need to find intersections. So when we overlap these two, they both have what part in common? They both have this part in common. So your number is between 9 and 4. Now, sometimes instead of, when you have a compound inequality, instead of writing two separate inequality and put the word and, we just write it like this. We put like these problems. We bonded between two numbers. You bond your expression between these two numbers. So it's bonded between these two numbers. So in that case, let's say if you just have it like this, to solve this equation, what would you do first? You add 10, right? You add positive 10 here and positive 10 there. Okay. When you have this type of inequality, you should add to all three of them. That's how it works. Whatever you add or subtract, it has to be done to all three of them. So this would be x is between 25 and 21. X is bonded between these two. So if this is 25 and this is 21, that's how you do the graphing. X is always bonded between these two numbers. So this is another way of showing the intersection with the, let's look at these problems. See, if I have a problem just like this, what would I do first? Don't I have to move 19 to the other side, right? So I add 19 here and 19 there, correct? So now you have to also add 19 here too. Whatever you add, you have to add it to all three of them. So 3x is less than 21 and 0. Now, if I have just one inequality and it's 3x less than 21, what's the next step? Divide by 3, right? So you do all 3 of them divide by 3. So we understand that 0 divided by any number is always 0. Again, you could use your calculator to verify that. Three goes to 21, 7. So x is bonded between these two numbers. So you have to use the bracket because we have an equality sign. Okay, that's how you show your graph. This is again another way of showing overlap. Now the next is when we use OR, union, solve the compound inequality. X is less than 4 or x is less than 8. X is less than 4 x is also less than 8. See? See, imagine this one has all these numbers. It has 8, it has 7, it has 6, it has 5, it has 4, it has 3, it has 2, it goes all the way. This one has 4, 3, 2, 1, all the way to minus infinity. Union is you collect all the numbers and you put it in one place. So this one already has all the numbers that exist here. Okay, so the union is 8 in one end and negative infinity on the other end. That's what the union means. You collect all the numbers with no repetition of the number. You don't have to repeat. So again, this one already has all 7, 6, 5, 4, 3, 2, 1. So we don't really need that. We already have this basket has all the number that exist here. That's what the union means. The other one was intersection was overlap. No, this is all the number considered. X less than minus 7 or x greater than equal to 8. You could even do it in one graph. Look, if minus 7 is here and 8 is here, 8 is greater than 8. X is greater than 8. Here is less than minus 7. See? So now if you want to write that in interval notation, so the solution set you write it like this: minus infinity and minus 7 bracket. The other one is 8 to infinity or positive infinity, right? Now, when there are two pieces like this, for you to connect it, you use the symbol of union. When there are two separate pieces, for you to connect it, when you write the final answers, you got to put this on symbol of union. Another compound inequality. X is greater than 2 or x is less than 3. X greater than 2. X less than 3. Look, it's or. When you combine all these two, this one already has 2, 3, 4, 5, and this one has 3, 2. So all you have is when you combine these two together is negative infinity to positive infinity. You know, you take all the numbers from 3 to negative infinity, you throw it into the basket, and then when you want to throw all the numbers for this one, you don't need to put these two again. So you start from that 4, put all the 4 and greater and put it into that basket. So your basket has all the numbers from negative infinity to positive infinity. Another one, negative 2x less than equal to minus 8, or 6x minus 21 is greater than 15. All right. Now again, when I divide both sides by a negative number, you gotta be careful. We have to remember this one. We have to switch the sign. The symbol would be now greater than equal to 4. Here, x greater than equal to 6. So you have these two. One has all the numbers greater than 6 to infinity. The other one has all the number greater than 4 to infinity. Right? When you combine these two, this one does have all the number that already exists here. So your union is this. So your union is bracket 4 positive infinity. See? Because again, this basket has all the number that already exists here. Like this one has 6, 7, 8, 9, 10. This one already has that 4, 5, 6, 7. So you take these, and that would be your answer when you're talking about the union. X plus 8 less than 0, or 4x is greater than minus 28. X is less than minus 8. Divide both sides by positive 4. See, we are not dividing by negative, so we don't have to switch the sign. We are dividing by positive. So x is greater than minus 7. So remember, you change the sign when you divide by a negative number. It doesn't matter whether you have negative here or not, but we do not divide by negative, we divide by positive. So these are what you have. So if you have these two numbers here, look, if you have negative 8 and like negative 7, one is x greater than minus 7, and is a parentheses because it doesn't have equal sign. The other one is goes from, see, one goes from minus infinity because it's less all the way to minus infinity, the other one from minus 7 to positive infinity. So union, or union means you have all this. So you have negative 8, parentheses, comma, minus infinity, and you have here minus 7 and positive infinity. How do I connect this to use the symbol of the union? U. To combine and write answers. I distribute 5 first. So you have it. So x is greater than 4. And less than 7. Okay. Now, when you combine these two, this one has all the numbers from 7 to less, and this one. So when you combine it, what do you have? You have all the numbers from minus infinity to positive infinity. That's the answers. So you put both together to find all the numbers. There's another one. It's and let's look at this one. X is greater than or equal to 0. X is less than or equal to -1. X greater than 0. And this one, look. When you overlap these two, they don't have any intersections, see? So the solution set is what? Is 0. They don't have any intersections. They don't have any common set. They don't share any sections together. You could always pause any of these problems if you see I'm going fast because we are not in the class, and you could always pause the video and copy. Now, this is a problem that is intersections, right? Because it's between, anytime you are between these two, means is and, is intersections. All right. To get rid of that 3, the best thing is multiply every number by 3, okay? To get rid of that. So 3 and 3 cancel, 3 times 0 is 0. So 0 is 4 minus 5x and 12. So this problem is not that easy. So you do that first, so you get rid of denominator. Now I want to move negative, I mean to move 4, so I put the -4. Now, I divide all of them by -4. 5. Remember, when you divide by -5, the sign change. See? X is greater than -8/5 is a negative number, right? So let's say somewhere here. And this positive number is greater than X, means X is smaller than that. Okay, that's how you graph it. Another one. So when I distribute 5 first. Then I add 15 to all 3 of them. Then divide by 5. Remember again, 0 divided by any number is always 0. See, X is between these 2 numbers, okay? So X is always between 21/5 and 0. Like that. X is between these 2 numbers. And now we go to the last problems. 4x plus 1 less than 5, or 6x is greater than 25. See, these are the problems that, since you come in with the fractions, you could always divide and see. It's obviously 25/6 is greater than 1. So it's like 4.2. This is like x equal 4.2, right? So, and it's or. So one is x is 1 and less. The other one is 4.2, which has to be on the right side of the 1, or 25/6, and goes to the right. See? And if you want to write it, the answer, you could write it like that: -infinity and -1 union 25/6 and positive infinity. And you don't even have to write a positive infinity. If you just write it like that, it means the same thing. Okay. Alrighty. So that would take care of